Now next one is binary search tree assignments. Now this one has the same approach as the linked list approach we had it. We'll have various exercises and some code snippets to solve that exercise, but there is a catch. The code has some issue. It does not solve the exercise correctly. What you have to do is that in each code, find out which line is wrong and what will be the correct statement in that line. Okay. Now here it is first exercise. Although it says exercise 3, but there is numbering problem. But let us leave that part. Here is a code to remove the node storing element E in a binary search tree and root V. You have to find out, will this code work? Is the code correct? If no, explain what needs to be changed in this code to make it do that. What your assignment is that please go ahead and write this code and try to test out and find out what is wrong in this code. Here is another example exercise. Here is a sample code which is used to find the largest value in a tree. So tree is given and this is the root node. This is the tree object and this is the root node. You have to find out which node has the largest value in the tree. And this is the code which is written. Will this really return the largest value in a tree? I don't know. Find out. Same example here. Will it return the smallest value in a tree? Try to run the code and find out. These two are assignment for you. And in most of the cases, there will be a small change in a line here and there, and the code should work fine. There is not big changes. You don't need to write 10 lines of code or change the whole code itself. Most of the time there is a one line of code change if you understand the logic. Here is a code to visit all the nodes in a binary tree in order, starting from root node. While visiting a node, print the data in that node. Is this code correct? It is an in-order traversal of a binary tree. Check if in-order traversal of binary tree is correct or not. In this code, just to understand, here I am creating the tree by inserting root node, and then I am calling print in order, which is this method, to print the node in order. This is nothing but just to add the node in the tree. This does not do any logic in traversal part. This is just for creating the tree. If you don't have a sample code of creating the tree, you can take the sample code from here and use this method to create the tree. This also helps us as an example how to create a tree from a node object. Next exercise. Here is a code to find the depth of any given binary tree. Reference to root node is given. You have to find out, is this code correct to find the depth of any given binary tree? If no, explain what needs to be changed in this code to make it do that. Given a binary tree of integers, print it in level order. The output will contain a space between the numbers in the same level and new line between different levels. For example, if the tree is 1, 2, 3, 4, 5, 6, it is not binary search tree, it is a regular binary tree. So it is, although it says binary search tree exercise, it is a binary tree exercise, because you might have seen that this is no more a binary search, it is a regular binary tree, because 2 is not less than 1, 4 is not less than 2. Anyway, it is a binary tree, and you have to write a code so that the output will be 1, 2, 3, 4, 5, 6, like this, all on one level, starting like this. Okay. Here is the solution. Now, some of the discussion questions which happens is that, what is the maximum number of nodes in a binary tree of height n? What is the maximum number of nodes on level k of a binary tree? How many different trees are possible with 15 nodes? In tree construction, which is the suitable efficient data structure? Array, linked list, stack, queue, or none? Now we have pretty much completed the data structure and algorithm part. Data structure part, we are still not done the algorithm part of sorting and all, but basic data structure we have completed. So we will review some data structure questions. In this review, what are the areas in which data structures are applied extensively? One is that compiler design. In compiler design, lot of stack data structure and tree, especially the abstract syntax tree kind of a data structure is utilized very heavily. In the operating system world, the tree data structure again for file system, queue data structure for request processing is used heavily. In the data management system, array data structure and tree for hierarchical DBMS is used. For statistical analysis packages, the graph data structure, the tree data structure is used. For numerical analysis like search, expression evaluation, array and tree data structure is used. So if you have noticed one thing, that there is one data structure which get used quite a good number of places, and that is tree. See that tree. You see how important is tree data structure? Now, do you think that you can still do a good software development job without understanding the tree data structure? It is almost impossible. So you must understand the binary search tree, binary tree, complete, and different types of binary tree, full tree, complete tree. You must write lot of sample codes in the tree data structure to understand the real life application of a data structure. And tree implementation behind the scene is using the linked list. So then behind the scene you need to understand linked list, because most of the tree data structure uses linked list for implementation. Okay. So linked list and tree are one of the most important thing to understand. Which of the following data structure cannot store the non-homogeneous data elements? Find out, tell me the answer of this one. Pointers can store, arrays cannot store. Okay. Now, what data structure? Now, these are the questions for your own brainstorming and discussion. What kind of a data structure you will use to store a set of programs which are to be given access to a hard disk according to their priority? Is it a priority queue? For representing a city region telephone network, will it use linked list? To remove duplicates, will you use set? To implement back functionality in the internet browser, stack? To store dynamically growing data which is accessed very frequently based upon a key value, find out. To implement printer spooler, priority queue or queue? To record the sequence of all the pages browsed in one session, stack. To implement the undo functionality in a text editor, stack. To store information about directories and files in a system, tree. So these are the various application, real life software applications of various types of data structure in real life. Okay.